Thank you. It's already late, right? I hope you have some energy. I'm definitely going to try and make this as pragmatic as possible because this is really just a story about what we did. So I hope it resonates with you. So you already know me, so I can skip this part because I told this morning, right? I work for Schuberg Philis. Schuberg Philis is an outsourcing company in the Netherlands. And what we do is we outsource mission-critical environments. So we have about 300 people and about 16 customers. So you can imagine every customer is very big. And what we do is we have this single KPI, which is 100% customer satisfaction. And we thought from the beginning, let's do things differently. If you really want satisfied customers, you need to have people who can have the mandate to act on whatever the customer needs. So as I said in the morning, we have no managers, and the team has the mandate to act on everything that's needed to satisfy the customer. And that works out pretty well because these are some of our customers. I think some of them are also known in Greece. Maybe ING, for instance. We have a lot of banks and big supermarket, governmental agencies, stuff like that. And it actually works quite well. This is the last slide in the company because we are way over here. And this is a research that's independent about how satisfied customers are, and they are really happy with us, and that's really cool to work there. So then on the pragmatic part, right? So why focus on security? Because I always used to kind of hate security because it was a lot of paper, it was kind of a slow and low energy thing. And for me, it kind of changed about 1.5 years ago. And now I think it's one of the most fun subjects to talk about or to talk about with people. And that's kind of a big change for me. And I hope it will do the same for you, actually. So how did I start doing things in security? Well, basically, we have Agile and we have continuous delivery. And Agile was about making things small. So we are used to doing big projects, big waterfall things, right? And then Agile said, okay, let's think of the very smallest thing we can think of to deliver to the customer, to add value in an experimental approach. And then next came continuous delivery, which said, okay, when we build things small and when we think of them in a small way, let's also deliver the value to the customer so that he or she can use it, which is great, right? So continuous delivery helped to reduce the time and the risk and the cost of actually giving the functionality to the customer. And those two things really changed a lot of things in our field. So what you see is there's DevOps, there's people working in teams where you build it, you run it. So traditionally there were these huge checks when you handed over functionality to your colleague who was mostly at ops or something. And there was a lot of checks and pen testing and code reviewing to make sure that this handover, that the code was good, that was safe, that was secure. There was also probably some security guy who was checking all the code. And we're trying to speed up, and actually all those things are changing. So we see self-organization, we see all the new architectures trying to support Agile, trying to support continuous delivery. We work in containers with immutable infrastructures in a cloud somewhere. And how does this all affect security? That's kind of the main question I was trying to answer. Like, yes, we were safe, but are we still? Because we were working in this mainframe that was in our basement, and we just aren't anymore, right? And what's the impact of this? Do we really know what we're doing? So, to me, focus kind of shifted to speed and nothing else. And I was wondering, are we still safe with all the shifting panels? So if you look at cloud computing, at the company I was working with, we had all the customers, that was the previous company, had about 2,000 customers, and each had their own customer data in their own data center. And then we thought it's a tremendously good idea to actually get this big data pot somewhere on AWS, because if we manage it, it will save you a lot of time and cost, right, as a customer. But we're also creating this huge honeypot where suddenly all the data of all the Dutch inhabitants was somewhere on AWS, there to hack for somebody. And it was really different than having just this little particle, right? And IT is also penetrating a bigger part of all businesses. So it used to be that only this one business process that was really critical was automated, and now you see that everything's being automated, even the smallest things. So there is so much data we are collecting, and it also really changes risk. And lastly, if you look at all the current developments in IoT and AI, machine learning, that's also really changing the risks we are facing, right? So there's a lot of things changing. Are we really thinking this through? And also, people are changing. Because we used to have this architect somewhere, we used to have a security department that was challenging everything. And we used to have management with a certain role and things like project initiation documents and stuff like that, right? And it's all gone. Well, at least at a lot of companies, we're doing things really different. So people are doing new things every day because we're telling people you should be key-shaped or P-shaped or T-shaped. So basically it means you need to do a lot of things you did not do before. And all those things, you are doing it for a first time. So do we really know what we're doing? Can we honestly say, yes, when I implement this piece of code in this new architecture, in this language I did not do before, I'm doing it in a safe way? Well, at least I wasn't sure anymore. And I did not want to be that company that get into the headlines like, wow, what a data breach. So, and then I found this tweet, and within 1 hour it had like almost 2,000 likes, where it says, software culture does not understand prevention. And I think it's true. I think most of the developers are basically really creative people. And creativity is so great, but I hardly ever, in a session, hear people raising their hands like, can we make this secure? It's not a popular question to ask, right? So there's kind of group pressure actually to say, how can we make this look really cool? That's a cool question, not how to make this secure. So if you look at the state of the cybersecurity report in 2017, it said that fewer than half is confident that they are doing secure software development. And mostly, when I ask people in the room, I get very few hands who can here say that they are confident that they are doing secure software development. That's cool. There's always a bunch. And I really urge you to also come and tell those stories, because they need to be told. Because some people are doing things really differently, but it's just quite a few. So this voice needs to be there more. So what I thought is, everybody has a CISO, somebody in charge of security. We're paying a lot of money on security everywhere. We're writing tremendously amounts of pages telling things about security, but we don't have the feeling we are secure. So what is this? Is this security role play where we're just imagining that we're safe, so that we have kind of cover your ass story whenever we have a data breach? So I thought, okay, how can we change this? So that's the moment where I thought I'm going to do security all in. I'm going to kind of explore what's out there, and I'm going to try and do this really differently. So basically, I'm not an expert. I started on security 1.5 years ago. If you put your mind to it, you can definitely know much more than I know at this moment. So there's really a lot to gain if you just spend some love and attention to it. And there's always one rule for myself, like, okay, when I'm going to do security, I'm not going to be this guy or girl, because I don't like to be the one who's always nagging, like how we can't go to production. I want to be on this side of the ball, right? I want to help push the value out, and I don't want to be the one stopping value. So when we're doing this, I want it to be fun. I want it to be actually helping instead of stopping development, because I don't like it when I'm stopped. And this one was quite good for me. This is Randy Shoup. He works at WooWork, and he previously worked at Google, kind of a famous company. And he said, I never once spoke with the security team at Google, not because they weren't doing their job, but exactly because they were doing their job. So they encoded their expertise into self-service tools and libraries, and we just used them ourselves. So security can actually help you speed up instead of stop you, right? So then the first thing you ask is, what is this continuous security thing? What is DevSecOps? It's also the popular term for it. And it turns out there's no definition yet. So it kind of also points out that it's getting little attention, right? So I started with the definition of continuous delivery, which is a set of practices and principles, and that's aimed at building, testing, and releasing software faster and more frequently. And they help to reduce time, risk, and cost of delivering software. And if you look at the definition I made myself for continuous security, because it isn't there, right? So I gave it my best shot. Then it's still a set of practices and principles aimed at designing, developing, testing, and running software more securely. They help to reduce the cost, time, and risk of delivering integrity, availability, and confidentiality, because security is all three, right? It's not just making sure that nobody enters your system who should not be there, but it's also that it's there when you want to enter it. So security is also that when you want to make a payment, that your bank is online and that you are able to do so. And also that your data has integrity, so that when you look at your bank account, that it says a balance that actually is right and that nobody altered the data. And continuous security is essential for delivering continuous delivery. So don't do continuous delivery if you are not in any way doing continuous security. And then we just started. I shared the story with the team, and then we said, let's go ahead, because Aristotle, he's from Greece, right? So for the things we have to learn before we can do them, we learn by doing them. So basically, we just went ahead. And when I look back at how the story went, because I think we came a long way, well, I kind of restructured it because afterwards I read a report that was kind of interesting. So what I did afterwards was I structured the talk against this Gartner DevSecOps top 10 steps, and it's like a practical guide to get started on DevSecOps. So I just structured all our things in this way because it's quite helpful. And on the last page, there's this page with all the sources. So if you want to check them out, that's, I will be sharing the slides. So what they say is you have to have security champions. Don't eliminate all the risk. It has to be driven by DevOps teams. You have to identify and remove first. You have to do context adaptation, eliminate known vulnerabilities. You have to think about an immutable infrastructure, detection of changes, security tests are source code, and lastly, train for the basics. So the first one was really cool to do, have security champions. Because if you want to do continuous security, it has to be driven by the team itself. And as long as you have this different department with security experts, you can never have the responsibility and the mandate within your team. So it needs to be people who are in the team. Just like you don't want an ivory tower with architects, you don't want an ivory tower with security experts. So you have to have security champions, and they have to be in the team. You have to educate and coach them. So what we did is we have this structure where we have SEC leads and SEC buddies. So yes, we still have a center of expertise with security people, but those people are there to coach the SEC leads who are in the teams. And that's a really proper way to actually get security knowledge on board of the team and to get discussions running. And the people from the security department have the time to actually investigate something more deeply and more thoroughly. But they never do anything without also relying on the SEC leads who are in the team. And this is what we did at a previous company where we had this security satellite team, and we just asked people who's interested in doing more about security. So don't appoint people, just ask who's interested in learning this, because it's really fun to do so. And we had a bunch of people, testers, developers, people from ops, and they were collaborating, and it also really grew, for us, it also grew the DevOps business, so it was also a good side effect of it. And next thing is, don't try to eliminate all the risk. For instance, if you look at this report, this comes from our pen test, and there is this finding in a pen test that says there's a phone number in plain text. And what you can do is when you're working on a screen, somebody can look over your shoulder and see this phone number, right? And that might be a security risk. And this came from the audit of one of the big accounting companies. And it does say that it has a low risk profile, But I really, really pushed back on this because this phone number was after logging into your bank account, because our customer is a bank. So you could see your balance, you could see all your payments, and yes, you could also see a phone number. You could also see a name. There's a bunch of stuff. It's meant to have data, otherwise you can't use it anymore, right? So we actually worked hard to get only findings in the report that were relevant. Because as long as you're telling a group of developers that there's a risk where they should focus on, that nobody understands, that nobody really gets, then you're working on something that you're losing on energy on. So it's really important to push back and to only focus on those real risks. So we got it out. Basically, what you need to do is you need to align security needs with business value. Just as you're not testing everything, you're not pushing out every little bit of functionality you could possibly think of, because some things are just low priority. And it's the same thing with security. There are risks that you need to ignore, because the amount of money you need to pay to actually automate this security will be more than the risk ever will be. So it's okay to have risk, and that's really a mindset you need to grow. So the next thing is you need to be DevOps driven, and it's really important that when you go to continuous security that everything is automated, because there's no time to check things by hand, just as you don't have time to do manual testing, right? So it's kind of the same principle. And I think this tweet message actually gets it quite right. It should not be like this, where there's the DevOps team pushing out a lot of production and there's somebody from the SEC team who's cleaning everything up that the other people messed up, right? It should be a collaboration. So when you have the SEC team, as the SEC lead on your team, make sure that he does not get to be the unpopular person, right? I mean, you need to actually collaborate on things and make it a broad thing. It's not that this is the only guy or girl who's now responsible for security. You're all responsible. This is just the one who's pushing it. Basically, this one from Tiago de Faria, if you're doing DevOps without security, you are doing it wrong. And I really believe this. So try to shift left on security. Don't have functionality being thrown over the fence for some SEC lead to catch it. It has to be a collaboration. You have to look at it from multiple angles. So what you do is you automate security in. And if you start automating security, you'll be facing these terms. And they were quite new to me about 1.5 years ago. So there's a SAST, there's a DAST, there's some proxy tools, dependency checks, and there's some custom scripts. And these are all part of your automation on security. So a SAST is a static analysis security testing, and DAST is dynamic analysis security testing. So one does your code before it's compiled, and the other one does it at runtime, right? And then there's a bunch of other things, so I'll just pass them by one. So as I said, SAST is source code security testing, and it does your code before compilation. And that means that it's really fast, because you don't first have to compile your code. You can immediately run your security checks at the moment you're writing a line of code. So that's great. And you get very detailed feedback. So it will point out which line of code has the vulnerability in it. So you don't have to search your whole code base, like where is this mistake or where is this potential vulnerability. It will point out very precisely. But it does have some drawbacks, because it has a limited scope, and you leave configuration out of scope. 15% of your security incidents will come from your configuration files, and it's like this big blind spot. We're not testing it, we're not looking at it, so please change that. And it has a lot of false positives and a lot of false negatives. So that means that sometimes you will see some vulnerabilities being pointed out that actually are not a vulnerability, because they are fixed somewhere else in a different class, in a different part of your code base. So when you get that, you need to adapt it. So if there's a false positive or a false negative, you need to make sure that the rules are changed so that you don't keep getting them, right? And the second thing of automation is your DAST. That's your dynamic application security testing. And there's this does vulnerability testing, security testing at runtime. So it's a reliable resemblance of how attackers will be facing your application. It's the way they will be using it, right? And So that's really a realistic view, and that's the positive part of doing dust testing. But it's more complex, it's harder to track, and it needs a running instance. So that means that you first have to be able to compile your code before you can find a vulnerability. So it's more costly to find a vulnerability at that point. So it's really optimal to combine both. And it's not so expensive because for both there are open source variants. So for SAST we used SonarQube. And there is a bunch of rules, but you do need to look at the rules. So it does cost money to configure it. And there's also a bunch of paid tooling, of course. And if you are wondering which one is the best for you, if you go to OWASP, which is one of the main security projects on the internet, right? You will see that there is an analysis of all the Dust and SAST tools by the amount of vulnerabilities they are able to find in similar code bases. So that will help you to actually find the one that's most appropriate for you, because it depends on what language you're using, what architecture you are using, which one is most suitable for you. But you can actually look at it because it has its own strengths and weaknesses. What we also did, we introduced evil user stories. So this is part of the custom script. And it's just like a user story. But now, think as a hacker. So as a malicious hacker, I want to gain access to this web application's cloud hosting account so that I can lock out the legitimate owners and delete the servers and their backups and destroy their entire business. So that's a use case for a hacker. And whenever you find that there's a vulnerability, whenever you find that there's a hacker trying to do a DDoS attack or something, you can actually simulate this story and automate it. So if you're, for instance, depending on an IP whitelisting or something, with a malicious user story, you can check that the whitelist is still in place. That would be a valid evil user story, one we definitely have in place, because it might be deleted, and then you're suddenly exposed, right? And if you're depending on your repositories to be private, that's also a valid user story. You can test it. It's not so hard to write this script. And then you make sure that you're safe, because otherwise it's just one setting where you set it from private to public and everybody can see it. That's not what you want. So what we also did, more on the infrastructure part, we have this security policy where we say this is how your web application firewall should be, this is how your antivirus should be, it should be patched, it should be updated. So we write all these policies, right? The security department does it. And then they found out that in practice, there was quite some differences from the security policy with the way things actually were configured. So what they did at a certain point is actually they checked in the pipeline if all the best practices were followed. And it was quite easy to do so, just to try and see, are there any differences? Because we did not write this policy for nothing, right? So, and whenever there's a deviation, sometimes there's a real use case to have things differently, because otherwise, I don't know, it just doesn't work in your own setting. But then you need to register the deviation and make sure that people deliberately make an exception and that it's validated and that actually changes it. So what we also found is the fourth rule. You need to identify and remove, and you need to start small. So if you are going to do continuous security and you're going to plan a project of about 1 year or something before you start, that's really a lot of waste of time. You're making code here, so just handle it as an MVP, handle it agile, just as all your other code. So just start and make sure that whenever you find a vulnerability, you actually fix it. And it sounds like a real cliche, but we quite often forget that when there is some vulnerability being measured by a SAST or a DOS tool to actually fix it. So what we did is one guy from the security team, he just added 100 security rules in SonarQube, and then he communicated about it. So he sat down with the other developers and said, okay, this is why this vulnerability is being reported. And this is the vulnerability that we're exposed to, because a lot of times it turned out that we did not really understand why it was reporting it. And if you don't understand why, you don't know why you have to fix it, you don't get any energy from fixing it. So make sure that you spend time on people, coaching them, and rather that you fix 3 vulnerabilities that are being reported by Sonar, instead of just sending lists of 2,000 vulnerabilities to your colleagues, because they will ignore them. So get there step by step and take it one step at a time. It's the same thing with the dependency check. There's this free open source dependency check from OWASP. It's one of the top 10 projects. And a dependency check, basically, you import a lot of third-party libraries, and those third-party libraries might have vulnerabilities. And whenever a third party finds that it has a vulnerability, it will state so in a central vulnerability database. And from that point, your security is really being compromised, because before, hackers did not know of the vulnerability. But after it was reported, everybody actually knows that it has a vulnerability. So if you don't patch it, you're at real risk, right? Because it's really exposed. And what you have to do then is automatically scan if there is any vulnerabilities being reported in the central vulnerability database. And if you have some of the third-party libraries in a version that still contains this vulnerability. And when we started doing this, we actually got hundreds of vulnerabilities in a code base that was less than a year old. That was quite terrible, actually. But we did solve them within a day by doing a lot of critical upgrades. And it was not really so much work. So it was really a shame that we were exposed to this risk, because it was quite easy to fix. And we also removed a lot of obsolete dependencies that were just there, and we did not use them anymore because we experimented with it and it had no value or something, but it was still in there. That's why they weren't patched. But code, even when it's not being used, can still expose you to this vulnerability. So you actually need to fix this. What we also did, we ran Docker Bench. We had a lot of things running in Docker. And we found that a lot of privileges were being too high. So we actually corrected them, and that was also a good fix. So there were users with administrative privileges that just should not be there because we had this immutable infrastructure. So there was no admin user needed who could adjust a bunch of things, because we don't want the infrastructure being adjusted by hand. We wanted it being pushed out by code. So that actually gave us a big uptime. And also, there was this guy who had this internal learning platform. People had a lot of more access to resources where they could find a lot of knowledge on security, and they did not have access to it before. And it also improved things. So the next thing is you need to have context adaptation. Basically it means you have to learn and adapt first before you break the build. So what you don't want is when you have these SAST and DAST scans and when you have a lot of security testing, is that you break the build before truly understanding what these rules mean and what these rules apply and why these rules are here. Because if you don't know how to fix them, if you don't know why they are here, and you're breaking the build, that's really, really a bad thing, because you're stopping the teams from delivering value. And they're doing it now anyway, right? So you're not exposed to a new risk. Try in everything you do to just add value instead of stopping value. So one of the things we did, there's this application security verification standard. It's also one of the OWASP top 10 things. And it has a bunch of rules. It's 80 pages. And it's 80 pages of these kind of tables. This is just the top part of it, of one of those pages, with all the rules in it on different levels. So when you give this to somebody in the team, they can never get their heads around this. It's really complicated. Don't try to overload people with information and hope that you'll be secure, because you won't. People will ignore the document. So what we did, we removed a lot of rules because they were irrelevant, because they were already being checked by a SAST tool or by a DAST tool. So those were risks we were not exposed to anymore, because there was something automated checking it already. So nobody needed to memorize it. We still need to explain it, but you don't need to memorize it. And we also removed a lot of rules that were just not relevant in our situation, because it was not applicable for us. And when we did, we removed so many of these line items that we only were left with 3 pages in the end. And that was something that people could memorize, and that was something we could talk about. So that was really a big uplift from where we came from. And we also want a lot of security up front, because if you try to fix things at the end, it's really costly, right? So what we do is also tailor-made checklists. Like in our situation, these are important considerations, and it's just an assessment you can quickly do, and you can get help from somebody from the security team to make sure that you're thinking about all the relevant elements, in this case of using a third-party service. Because if you're using SaaS services and you're putting your data somewhere, you need to investigate how are they handling my data, and are they also protecting the data of our customers in the way we think we should protect it. So you need to look at your security policies on that part too. And the next thing, also really kind of straightforward, is you need to fix your vulnerabilities. So what I said is, with the OWASP dependency check, we actually had to fix all the vulnerabilities we found. It was 550 vulnerabilities, it's really a lot, but they were fixed in one day. And this was one of the other systems, and you could see that the security checks were now running in the pipeline, and that they were reporting all the vulnerabilities. But make sure that somebody's looking at it. Even if you don't break the build, spend some love and attention on it, because otherwise people might ignore it and you're still at risk, right? And you don't want that. The next thing was really interesting, and that's the immutable infrastructure. So I know that not everybody has the opportunity to move to the immutable infrastructure, because the system just won't be able to cope with that. But if you are using an immutable infrastructure, then definitely this is for you. And if you are not, there are still some things in the mindset that you can really use, even though you don't have this immutable infrastructure. So Tifo Koren from Aqua Security says one of the benefits of using containers, especially in microservice-based applications, is that they make it easier to secure applications via runtime immutability, or never changing, and applying least privileges that limit what a container can do. That's a lot of words to say you don't need to have an administrator account anymore. And that's a big thing, because whenever a hacker will get into your system, it will definitely go for this administrator account, right? Because that gives you all the privileges. So if you think of your immutable infrastructure just as code that you only change following the pipeline, then if there is this thing with your server why it's not running, then fix it in the code. Don't fix it by logging into your system and using this account, because it breaches your security level. And from the immutable infrastructure mindset, you can think patches are code changes and they follow the pipeline. So whenever you apply a patch, make sure that it's automatically being registered, like, okay, there is a patch available, we need to schedule it. Maybe when you run the patch, you can also do your test automation, just like any change follows the pipeline. So that's an important principle, to make sure that all your security tests are still running whenever you do apply this patch. And you can use systematic workload reprovisioning. And basically it means that you can randomly get out a container and put in a new one in place. And if you have a random schedule, just bringing the containers down and helping up new ones, and you have a failover structure where you can actually have multiple instances at the same time, then hackers will face constantly changing infrastructures, constantly changing addresses. And it's really difficult to persist when constantly your infrastructure is changing. And that's what you're doing when you're randoming, reloading, reprovisioning your infrastructure. So that's a huge benefit. And if it's automatically being pushed out, then it's quite easy to do so. It's more like configuration than having to build something. And you need to make sure that you scan your infrastructure against your security policy. It's what I said before. We have this security policy, and it's well thought through. So make sure that you also run some tests where possible to make sure that this policy is being followed. Because otherwise you are at breach and it's not even deliberate. And that's a shame, because you do have all the knowledge. And you also need to make sure that you apply pervasive visibility. It's really a strong sentence, but you need to make sure that you know what's happening on your system. And you can pick it up at the earliest. So using something like a SIEM that registers all the traffic in your system will truly help you to get an early sight on what's happening and to actually make sure that you're adjusting. So you also need to make sure that you can detect your changes. And I'm just going to briefly discuss this, but it's important that whenever something changes and you have all the security automation, that you can detect that something changes and that you actually run your security tests. So make sure that you have a pipeline for all code changes and that you're not able to kind of backdoor it. And it's the same thing with your security tests. You're writing code here, so you need to have version history, you need to have vision on who changed what in which version and why. So treat all your security code, all your security tests, just as you treat your source code, which is quite straightforward, but sometimes forgotten. And then the last part, and it's actually the hardest part, you need to train for the basics. And because basically, when you automate security and you move to this continuous security company, you can actually scan your features against bugs and vulnerabilities. But you can't check for logical flaws. So there is still this residual risk where you're exposed to. So for instance, if you have a microservices architecture, and you have all these RESTful APIs, and you follow the principle where you're quite liberal in what you accept, right? Then you have no services breaking whenever you change the information that comes out of the interface. Because, well, that's the way you structure things, right? So it might be that a certain application is receiving data that it just should not have access to. And there is no scan that will actually report this. It's just going to happen. And that's a logical flaw. That's a flaw in our thinking. And you also need to protect against this. And that's the hardest part because you can't automate it. So you need to make sure that you raise awareness on this. So basically, infrastructure alone will never keep you safe, right? So if you, for instance, look at the brute force time for the amount of characters of your password, then it's terrible. But this was kind of an old graph, because at this point, an 8-character password would take 115 days. And I just this morning looked up the new number, and now it takes 5 days, because we've improved. So at this moment, having a 9-character password will only keep you safe for 10 days. And most of the people don't know how a brute force attack will work. And if you see, there's tooling like Hashcat or like SAM Inside, and it will help you to create a brute force attack. And basically what it does, it knows what hash principle it's using, so it will just try to randomly guess a password and try if the encrypted hash is the same. So what hackers tend to use is there are all these databases with breached passwords, and it's passwords that are often being used. So they will first run those passwords because they are often used, right? People don't just use a random sequence of numbers. And what they also know is that most people are inclined to start with a capital letter, an uppercase letter, and to end with a number. So they can do a mask on these tools to actually run passwords that will be according this mask. So you need to educate people about how this attack works, because most people don't know this. And still, 10.6% of passwords is a top 20 password. That's terrible. So most of the hacks still are just from breached passwords. And you need to protect people by raising awareness. For instance, using passphrases, using two-factor authentication is much stronger than using passwords, because technology, as you see in the red numbers, will definitely catch up with the amount of numbers people can memorize. And what we did is, whenever somebody starts at our company, we first give them a security bootcamp. So before you get a laptop, before you get a badge, we first give them a security bootcamp. And it's a very strong way of bringing the importance of security along to the people who are working at your company, right? And what you also need to discuss is context awareness. So, for instance, this is an application, one app on your phone. It's called the Telegrass app. And basically, it was founded to trade in weed, like marijuana. And one of the founders of this application thought it would be a very good plan to have a strong identification of people, so that people would know who they are trading with. So it was obliged for people who were buying and people who were selling to upload their official identification, their passports. And they were telling people, yes, we make sure through encryption that nobody can access those documents. So within 8 months, the police actually imprisoned everybody who used it, right? Because you can't make sure that nobody enters your data. So start with the mindset like we can never be sure. And make sure that whatever you do in your system will never truly harm the people who are using it in a way that they can't recover from. And being imprisoned is kind of a life experience, right? Some things you don't enter as data into your system because it's simply too dangerous. Don't go there. And the other thing we did was really, really cool. We had this hack yourself first or hack yourself two principle where we gave education. And actually I'm really proud because this was one of the members of my team and he passed the exam for certified ethical hacker yesterday, so he posted it on LinkedIn. But basically it's kind of a chaos engineering principle. So you have to make rare events regular. And the amount of times that your system is being hacked by somebody who has really, really bad intentions, that's just too little. So you have to make sure this happens way more often. So what we did is we gave everybody, well, the group of people, a hacker training, certified ethical hacker training. And with this training, they tried to hack each other's systems. So that would mean that as a team member, whenever you push out code, you would know that at the end of the month, somebody from another team was going to try and hack your system. And that actually gave a lot of awareness to a level that was not there before. So Troy Hunt, one of the key people in security, he says, think as an offender will show the real threats of your application and grow awareness from finding out how easy it is. So you need to make sure that people hack regularly, because only being on the defensive side will never get the knowledge aboard about how easy it is to actually hack a system. So get one of those brute force password tools out on your phone, you can even use it, and try to actually brute force some of the passwords of colleagues. See how easy it is, you'll learn a lot. And then educate people, so use it as a white hat hacker attempt, right? So what we also did is social engineering is one of the main residual risk things, right? You can't protect yourself against it. So if you call them and they just give your data, how do you protect yourself against that? And it's only by telling again and again. And it sounds really boring. So what we try to do is we had this red teaming, and it's a company who will actually try to socially engineer your company. You can hire people to do that. So they will try to run to the door, oh, leave it open, you know, so that they can access the building. So we hired this company to actually try and social engineer us, and they send out cake to everybody who is not penetratable. So that's really cool, right? Because we got a cake because they found us unhackable. And just to make sure that you understand what the mindset is, one of the engineers, within a minute, he said, did you check the cake for hard and sharp objects before bringing it inside? So it's really sharp on awareness, right? And that's really a cool culture to be in. But on the other hand, this was kind of a cool story to tell until this one happened. So it was April Fool's Day, last April. And the security team thought, well, let's try to see if we're really unhackable. So what they did is they invented these really cheesy posters with a QR code, and whenever you would scan it, you would go to a false Okta page, which is our single sign-on thing, and 25 of our people out of 300 gave their true username, true password, using a cheesy poster on April Fool's Day. So that was not so good. And the security team actually got the seal of approval, what they are handing out every month, just as a joke to get more awareness, to make sure that people understand that they constantly need to think about security. So the seal of approval goes to whoever impacts security by something that's truly good. So I'm going to wrap it up. If you look at, again, the Gartner top 10 steps, I think it's a really nice guide to follow, and that you can improve within 6 months tremendously on your practices if you give it a little love and attention. So I hope it will be fun for you too. And that's it, actually. So, thank you. Oh, yes. And the sources.
Thank you, Kim.